ground, and now they've dried up and only flow for rainy seasons or in good years. So that's kind of been the trend of my research for the last 18 years, has been looking at what happens to biodiversity when streams dry up. Where we're at right now on the Santa Cruz River in downtown Tucson is a really fascinating case, because it's an example of putting water back into a river. So if you would have been here, 300 or 400 years ago, you would have seen a really lush agricultural sediment. The Tonahatam people had farms and irrigation canals down here in downtown Tucson. There's records going back 4,000 years to the Hohokam culture as well. Irrigation canals, ancient footprints preserved along the river. So the river has a really long history of water being important to people and to wildlife. What settlers did when they came here, especially started accelerating about 1870, was dig a lot more canals to the river, divert a lot more water away from the river, and eventually that, combined with some development of diesel pumps for pumping groundwater, led to the river drying up. So this river in downtown Tucson that had water for thousands of years was suddenly dry, except for times of floods. So that went on for 80 years or so, until just last May and June, when Tucson Water, our municipal water agency, started this experiment, which is called the Santa Cruz River Heritage Project. And so that water you're seeing in the background is treated effluent, or wastewater, from the city of Tucson that has gone through wastewater treatment plants, gone through a triple purification process, and it's almost drinking water quality, but not quite there yet. So it's safe to put in the water. It's in the rivers. It's safe to touch. It's safe to I'm in here all the time, splashing around. Sometimes I'm up to my chest in water. Totally safe water. And it's a way that we were able to put water back into the system. And so Tucson Water's goal was to start recharging the aquifer here in downtown Tucson and storing water for future use. But it has this side benefit of providing aquatic habitat that we can see in the background here. And so since they started that project, the first day that water was flowing was June 24th of 2019. And since that day, I've been out here, and my grad students have been out here basically studying how the wildlife is responding, what's coming back, how long it takes different species to come back to the river. Because it's kind of an unprecedented situation where we had a river that had water for thousands of years, dried up for a century, and now we've turned it back on. So what's going to happen? That's kind of the fun part.
I see. That's great. That's great. So take us through just a quick tour of what you study when you come out here. Where do you start?
Yeah, I start just over the hill here, where the water comes out of the Tucson Water pipe system. We'll step up in a minute and take a look at this marsh that has developed where the water's coming out. This marsh fills up and then spills out, as you can see behind us here. And as it spills out of the marsh, then it slowly kind of coalesces into a single river channel, which we can see behind us here, that's flowing north through downtown Tucson.
Okay.
And so we basically try to study the entire area that has water now. The amount of water changes through time for various reasons, but it's usually in the neighborhood of a mile or two of water. And so we'll come through here. We'll do surveys for birds. You can see the water heading downstream here. You can actually see some nice birds in the background. So we'll come out here, do surveys for birds, surveys for dragonflies and damselflies, for things like toads and snakes, garter snakes, aquatic snakes. Basically anything that needs the water is what we're interested in studying here.
All right.
So we could take a walk up if you want.
Great.
Watch your step here.
All right.
Okay, so now you can see kind of the heart of the Heritage Project. This is a large marsh where the water is coming out. There's these large cattail plants in the background, pretty lush, what you would see in a wetland just about anywhere. The unique thing is that this wetland is less than a year old, basically, right? This is a brand new wetland. It was great that we could put water back in the river, but a lot has changed since there was water in the river 100 years ago or 1,000 years ago. We have an entire city now that is developed around the river. And so that changed what the river actually looks like. In addition to going dry, the river was put into a flood control channel to protect the city of Tucson. And so that concrete bank you see rising above the cattails and in the background, that's all to protect the neighborhoods around here and the downtown businesses from flooding when the river's at high stage. And so that presents some complications, right? Because you have to maintain the ability of this channel to carry those large flood flows through and stop the neighborhoods around from flooding. So just 4 months ago, after the project had been going for 8 months and we were seeing a lot of this vegetation grow back, it was a wonderful success. It was really fun to watch the animals return. But we hit a snag, and that was that to preserve the flood control capacity of this river channel, the county had to come in and remove a lot of the sediment that had built up over the years. And so if we turn around and look behind me, you can see we're standing on a berm here. We're about 5 feet above the riverbed. And so that is because this 5 feet that you see below us here was bulldozed in January, and all that sediment was taken out of the riverbed and stored elsewhere so that we could increase the size of the river channel and allow these floods. Now, the compromise came in at that point in time. It was already an ecological success. We already had a lot of species here. So we tried to enhance the ability of the channel to hold more water. We tried to, allow them to do the bulldozing they needed to do, but also preserve some of the areas that had developed. And so that's one of the preservation areas, this wetland that we see here behind us. So it was a really interesting process to be part of trying to balance the needs of the city with the needs of the ecosystem. And I think we struck a pretty good balance here.
Have you ever done anything like that in your career up until now?
No, it was really interesting because, for two reasons. One is that normally when you collect scientific data, it takes, a couple of years to collect it. And then maybe if you're lucky, a year to do all the analysis and write things up. And then it takes another year or more to get it published in a scientific journal. And so you're talking 5 years after doing a project before anyone can actually read what you've been doing. In this case, we needed the information right away, right? We needed to use the information we were collecting about the biodiversity here to shape some of the management actions that needed to be done immediately. And so it was really intriguing and really cool to be part of a process where we didn't have to wait 5 years for someone to see our data and use it. It was used immediately in making some of these decisions. So that was a neat thing. And then the complexity of it was something that, maybe I had experience in a classroom exercise before, where I would give my students an example. Here's a really complex conservation problem. How do you solve it? But I never had tried to do one of those myself or be involved in facilitating it. So just for this project here, we have to work with and collaborate with the city of Tucson, which is Tucson Water, Pima County Flood Control District, which is the county, the state's Arizona Game and Fish Department, which manages a lot of the wildlife that live here, and federal U.S. Fish and Wildlife Service, which manages the endangered species that are found here. And then, of course, we've got the university as well, and nonprofits like the Sonoran Institute and community groups. So somehow you've got to get all of those people to work together to design some outcomes that are positive for the river ecosystem and for the city. So I would not say it's easy. There are a lot of stressful phone calls and a lot of, as soon as the pandemic started, a lot of Zoom meetings. But I think, being forced to do that in this project has made everyone a better communicator. Whereas before, the city might work only with people in the city and the county might work only with people in the county, and maybe a little bit of overlap, but this really forced everybody to be in a room together, which was a cool situation.
Great. So take us through some of the things that you might do when you come out here on a typical research day.
Yeah, so one of the big things that personally I do, we've got a pretty big research group, so we've got several graduate students, some undergrad researchers. But my favorite thing and the project that I really lead is the dragonfly component of it. The first day that water was released here last June, I came down just like 600 other people in Tucson did to come and see the water as it was first released. It was a big community event. And the first thing I noticed was that even within a couple hours of the water being on, there were dragonflies that had already flown in from somewhere else, a pond, a different part of the river, and were attracted to the new water here, within hours. And so I thought, oh, this is cool. I need to I need to study this. Like how did they find it? How quickly did they come back? Which species come back? And so I started doing surveys where basically dragonfly surveys are a lot of fun. All you do is you walk around and you look for dragonflies. And you take pictures of them, and if you can't identify them with your eyes, you have a net with you, and you try to net them so you can get them in your hand and get a good look at them. But it's a lot like birding, right? It's a pretty fun activity. And so I've been doing that at least every 2 weeks for the last year and a half down here, and sometimes as often as every day. When the water was first turned on, both last year and then this year after the construction. So I basically start here and I walk through this marsh. It's a little hard to see here, but there's a lot of water pooled up behind us here. And in those cattails, the water is about 2 feet deep. And so I'm out there getting soaking wet, walking through the water, systematically kind of slowly moving through and trying to find additional species of dragonflies and damselflies and keeping track of how many I see of each of the different species.
So how often do you see one of the dragonflies, like per minute or something like that?
That's another example of the success here, is that the densities are incredible. So you could come here, right now it's late afternoon, it's windy, it's not the best time because it's tough if you're a dragonfly trying to fly around in the wind. But if you were to come here at 10 o'clock in the morning when it's just warming up and the wind hasn't picked up yet, within a minute you could probably see 1,000 or more. Yeah, the densities are just incredible. And you'll see they'll be perched on all the grass that you see here. They'll be flying around up top. They'll be perched on the cattails in the background. So they are everywhere you can imagine. And some of them will be flying over the open water, like in the river channel down here. Each species has a little different behavior, a little different preference in where they want to live. So yeah, by the time I'm done with my survey, which goes from here downstream to a little bit past Star Pass Boulevard, to about 1,200 feet is the length of the survey.
So as far as the survey, what sort of coordinates are you following? Are you following the water as it travels? Or are you following the channel as you move down? So how are you doing that process?
Yeah, you're basically following the channel as you go down. This is a little trickier because it's a marsh rather than a river. And so what I do here is kind of walk in concentric circles to try to cover the marsh. And I'd spend about 20 minutes or so walking in this area. The total survey is 90 minutes, an hour and a half. So the first 20 minutes or so, 30 minutes I'll spend here. And then at that point, I'll leave the marsh and survey the main channel that we see flowing down here. And that's basically just walking, a combination of walking in the water and right on the edge of the water.
All right. Can we go down there and see that? It's a little bit easier to get up close to the water right down there.
So at this point, it's going to be really hard for the viewers to see, but there's already dragonflies and damselflies in here. The damselflies are really small. Here's one of the smallest ones we have, called a citrine forktail. It's just on the side of my finger. Hopefully it's showing up here. And I'll make it fly. There it goes.
All right.
We can walk down here and see if we see any others in the vegetation.
Sure.
Some of them, there's a lot of small insects, little fly larvae that emerge out of the water, especially as it warms up in the day. And so the dragonflies and the damselflies are coming in to hunt those smaller insects. And so they're often hanging out right around the edge of the water, and they're waiting for that little mayfly or that little true fly to pop up out of the water, and then the dragonfly is going to swoop in and get them while they're still fresh there. I'm trying to see if we could see any, we might even be able to see some of the larvae of the dragonflies. Here's somebody that you could probably see. It's a little water beetle moving along there.
Great.
Yeah, we can keep walking here and see if there's anything else. Just before we started the cast, we saw 3 coyotes that were right behind us here. And that's one thing, we see a lot of other wildlife on the river just coming in to drink. We see coyotes, javelina, hawks. Surprisingly, roadrunners, they are thirsty, thirsty birds. And so we'll often see 4 or 5 roadrunners in the same place, all drinking water at the same time.
Tell us a little bit about that video that went viral with the coyote chasing the roadrunner.
Yeah, that actually happened right here where we're standing. So I was up on the bank over here, that little rise about 5 feet high, and I looked over in this direction, maybe 50 feet in front of me, and I saw the roadrunner running and kind of running parallel to where I was at. And I thought, oh, that's interesting. And then I realized, it took me like a second to realize that there was a coyote chasing it, running after it. And so I immediately hurried to get my phone out so that I could capture this moment. And I got a short chase, probably 15 seconds, as the coyote's running after the roadrunner. And then it gets up to a point where the roadrunner finally decides, like, I've had enough playing around with the coyote, and it flies off. And that was the fun thing. So many people who saw the video were surprised that roadrunners could fly, because the roadrunner cartoon never flew. But real roadrunners can fly, and so I think they often just tease the coyotes and then fly away.
That's great.
Sometimes I can catch them with my hand, but
so what are you thinking of right now? What are you
these
catching?
are the damselflies that are in here.
Okay.
So you can actually see a good number of them flying around. That one especially might show up. Whoop.
Yeah.
Yeah, if I would have thought about it, I would have gotten a net. Nope.
That's a good beat.
Yeah.
So what's all the green here?
We're seeing a combination of things. So the interesting thing is we're seeing a lot of greenery, right? But none of these wetland plants were here before because there was no water. And so it took a period. They turned on the water last year. It took a period of about probably 5 or 6 months before slowly either seeds of these wetland plants got blown in from somewhere else on the wind, or a bird might have carried them in. But slowly we started to see these different wetland plants kind of pop up and appear here. And as soon as 1 or 2 of them got here, then they could start reproducing and flowering and sending out more plants. And so now we've got a pretty wonderful variety. Right here we're seeing a combination of the light green, which is duckweed, and that's one that often is transported on birds' feet. That's why it gets that name, duckweed. Then there's a lot of green algae, the bright green clumps that are within there. And then we've got, see if there's any flowers on it over here. Sure. This is a plant called speedwell that has a nice little purple flower. It's mostly gone to seed, but it's another one. So you're only going to find this plant with its roots in the water. Like, it would never grow up in regular soil. It has to be totally saturated.
Were any of these species that repopulated this area invasive, or?
That's a good question. So far, all the wetland plants are native plants. Some of the other things you're seeing, some of the grasses here, we do have buffalo grass, which is non-native. We have Johnson grass, which is non-native. So it is a mix of non-native and native species. And that's, when you're in a city, when you're in an urban environment, that's kind of what we expect. There's always going to be some weedy non-native species. So I guess I'm just pleased with the percentage of the native species and how well they've done. And none of these, we often, if this was a planned ecology project, there would have been a restoration effort. So when you turn on the water, people would have brought in the native plants that they wanted to see, and they would have planted them in a certain way so that they'd have a good chance of succeeding and growing. But this was more of an experiment than anything, and Tucson Water's main goal was to recharge the aquifer beneath us, and so anything else that happened was just a bonus.
Why is that important?
For the sustainability of Tucson's water supply. Right now, this water would otherwise be flowing in the river or recharged on the north part of Tucson or in Marana even. And so the farther away that our effluent gets recharged and goes into the ground, the harder it is to someday get that water back into the city of Tucson. And so it's more an idea of local storage for your water, right? Because you don't want to have to go 100 miles away to pump your groundwater back and take it to Tucson when you could just have it right underneath our feet.
Great.
Yeah.
All right. So this is one of the other places water is coming out. There was some upstream here. So
Exactly.
How does that work?
So because it was an experiment, they basically just turned on the water, and the water came blasting out at first across the desert. There was none of this greenery here, right? And it came right in this direction to about where we're standing here. And at that time, there were a couple of large tamarisk trees here, which are a non-native tree, but that's okay. And the roots of those trees kind of held the channel all in one place and held the water together and stopped it from eroding too much. What happened when they did the sediment removal here is they took out those large trees, because large trees will block the flood flows, right? So that was part of why they wanted to remove them. But what that left was this real barren slope, which is now being revegetated. But if you would have been here 2 months ago, you just would have seen bare gravel and nothing else. And so our fear was, when they turned the water back on, that it would just come blasting out like a fire hose and just erode all this bare gravel, and then the whole wetland would drain, right? So we wanted to somehow slow down the water, and instead of have it just come blasting out in one place, we wanted it to be more like a delta, where it spreads out and small amounts of water drip out here, small amounts here. And so that's what we did. We actually got in while they were doing the construction here and sediment removal. We got into the preservation area here and dug some canals and dug some channels to make sure the water kind of spread out and wasn't too powerful. So that was one of them. There's one here, and then there's another one you see over there. There's actually a fourth one on the far side that we haven't seen too. So it spreads out like that. And then those channels slowly come together here and then make the main river channel.
Let's see. And you said it goes about 1 mile?
At its lowest water level coming out, it goes about 1 mile, yeah. And when it's at full volume, when they're releasing as much water as they possibly can, it's been going about 2.5 miles.
Well, what were some of the plants that you would see before it got channelized, before it got dug out? What would it look like? How would it be different? How would it be similar to what we see around here?
It would basically be kind of what it looks like up above the river levees that you can see up there. So we would see scattered mesquite trees here and there. We would see an occasional Palo Verde tree. We would see things like creosote bush, small cactus. It was pretty much your standard desert. Lots of open bare ground like you would see in the desert as well, and scattered desert shrubs and trees. So nothing like the density of the vegetation you'd see here, and very little in the way of grasses as well.
I see. Well, thanks for talking with us. We'd love to have you on another broadcast at some point while maybe you have the net out while you're doing research. Yeah. So thanks for talking with us.
Yeah, thanks for the invitation. It's great.
And thanks for watching. My name is Eric Rosenwald. I'm on HAPS here. Broadcast to Facebook, Twitter, Periscope, a lot of other places. So you can support my journalism on the HAPS website. Just log in there and you can get going there. So thanks for watching. We'd love to be back here at some point in the future and get some more shots of this cool research that's going on in an urban desert